Hey everyone! In this video, we're going to be taking a look at one of the transformations, the translation. A translation is basically a slide. So what I would like to do is just talk through in detail what a translation is, talk about a couple of the properties about a translation, and then once we establish those things, we'll take a look at a specific example where we're going to translate an object. So to begin with here, let's just talk a little bit about what a translation is. So to do that, let's start with a segment. So I'm going to put a couple endpoints, and why don't we name these point P and point Q. And then I'll connect these together to form a segment, and then what we want to do is take this segment and translate it to some other location in our coordinate plane. Now when I say I'm going to translate it, that just means I'm going to slide this object somewhere else. Now just some terminology. My original object, so in this case my original segment PQ, we call that the pre-image. In other words, it's just our starting object. So now to do a translation, we are going to take every single point that makes up segment PQ, so our two endpoints P and Q, and everything in between, and we're going to move all of those points the same distance in the same direction. So for example, maybe I'll start with point P, and I'm going to slide this point to end up in this location over here. So point P is going to slide along this arrow, and it's going to end up right here at the end of that, and that's going to be the location after the translation. If point P, this was on my pre-image, my new point after doing my transformation, we call that the image. And I can notate that it's the image by using something called prime notation. So this is point P, and then I can label this new point P prime. So putting a little apostrophe on that point indicates that that's the new point. That's the location after doing the transformation. Now, I also have to do the same thing for every other point. So for example, point Q is also going to move that same distance in the same direction, and it's going to end up over here. And then just like we do with the point P, Q is our pre-image, and then this will be our image, Q prime. So that's going to happen for every single point that makes up this segment. So I'll connect these two together, and here is our image. So here's our object after the transformation. Now just a couple things about this. We are moving in the same direction, we're moving the same distance. So these two red arrows that I drew in, these are going to be congruent to each other. So they have the same length, we moved the same distance, and they're also going to be parallel to each other. So that means that we're moving in the same direction. So a couple statements I can write, I can say that the segment P prime, so the segment that connects together P to its image, that's going to be congruent to the segment Q prime. And I can also say that these two segments are parallel to each other. Now I'm just indicating this for the two endpoints, but this is also true for every single point that makes up these segments. Now one more piece to this, because all of the points are moving in the same direction and they're moving the same distance, the image that we end up with is going to be congruent to what we started with. So my original segment is going to be congruent to the image P prime Q prime. So those are congruent to each other. Now one last thing before we take a look at an example. These arrows that I drew in, so the direction and the distance that I'm translating my segment, a lot of times we like to say that we translate along a vector. So I could say that this red arrow is a vector. And a vector is just a directed line segment. So it shows you how far to go, and it shows you which direction to go. So now that we have all of that established, let's take a look at an example. So I have a triangle ABC with vertices A is 0, 3, B is 2, 4, and C is 1, 0. And what we want to do is we want to translate this along the vector -3, -5. Okay, so there's that word vector. So again, a vector, it's a directed line segment. So this tells us how far in the x direction to go and how far in the y direction. So let's start by graphing our triangle. So we have the points 0, 3, 1, 2, 3. So here's A. And then B is the point 2, 4. So that's right here. And then lastly, C is 1, 0. So I'll connect these together to form our triangle. Okay, so now we want to take this triangle ABC, and we're going to take all the points that make up that triangle, and we're going to translate the entire thing along the vector -3, -5. So that means every single point is going to move -3 units in the x direction and -5 units in the y direction. So maybe I'll start with point A. So I'm going to move to the left 3 units, 1, 2, 3, and then I'm going to move down 5 units for my -y direction. 1, 2, 3, 4, 5. And then this new point, this will be my image, so this will be A prime. So if I were to draw a segment connecting A to A prime, this would be my vector that I'm translating along. So now let's do the same thing for our other points. So B will go 3 units left and 5 units down. 1, 2, 3, 1, 2, 3, 4, 5. So here's B prime. And then lastly for C, 1, 2, 3, and then 1, 2, 3, 4, 5. And then that point will be C prime. So again, I will connect these together to form our triangle. Okay, so here's our image, A prime, B prime, C prime. And then just to relate this back to what we talked about initially, so if I draw in all the vectors going from my pre-image to my image, we should see that they are all parallel to each other. So these segments, these vectors, they're all parallel. They're all moving in the same direction. And they're also congruent to each other. So they all have the same length. So what that means is my new triangle, my triangle A prime, B prime, C prime, should be congruent to what we started with. So we can do that on the graph. We can just move all the points by counting it out, and we end up with our image. So that's our triangle after the translation. However, I can also do this algebraically. So this vector is giving me a rule I have to follow. So if I start with the point A is the point 0, 3, after my translation, I can find the location of A prime by subtracting 3 from my x values, because the vector is -3 here. So this is what we're doing to x. And then I can subtract I can subtract 5 from my y value, and I'll get my new location. So if I subtract 3 from the x, I get -3. Subtracting 5 from that y value, we get -2. So that's going to be the location of A prime. And I can do the same thing for my other points as well. So 2, 4. If I subtract 3 from the x value, we get -1. Subtract 5 from the y value. And then lastly for C, if we start at 1, 0, and then moving along our vector, we end up with, let's see, -2 and -5. So just doing a little bit of algebra, using our vector, we can move each individual point. That would give me my vertices, and then we could graph the triangle that way as well.